Hello, all. Welcome back to day 4 of our cloud computing session. In our previous session, we discussed about virtualization in detail, the primary factors that gives rise to virtualization, or the primary terminologies that makes virtualization possible were discussed. What are those terminologies? So we discussed how an application runs, how software as a service runs, what is an API, application programming interface? What is a ABI, application binary interface? What's the underlying instruction set architecture a physical computer would be possessing? How is the hypervisor going to abstract or encapsulate these details and serve the users with heterogeneous systems? What is a system call? How a system call gets converted from the request from the process to the hardware, and hypercalls. So what are hypercalls? Similar to your system calls, when a call is given by an application running on an operating system that goes directly to the hardware, you call it as hypercall. What makes this possible? The virtualization layer. What's a virtualization layer? A software layer that sits on your hardware, which enables more number of operating systems to get executed simultaneously or parallelly. So upon your operating systems, you can have more number of applications which can run concurrently without interfering any of the applications or operating systems running on your physical machine. So who does that? There is a software called hypervisor or virtual machine monitor, which is totally responsible for giving you an illusion or giving the operating systems, the applications and emulation environment to tell them or to show them that it is totally using the physical resources all by itself. So we have a technique or terminology called data isolation here. Data isolation. Every application that is getting executed in the hardware on your hypervisor thinks that the entire hardware belongs to itself. But that's not the case. Each application is isolated from the other application by the hypervisor. So that's about a hypervisor. And further, we learned about the types of hypervisors. What are the types of hypervisors we have? We have basically two types, which is the type 1 hypervisor, also called as bare metal hypervisor or embedded hypervisor. And we have type 2 hypervisor, which is called hosted hypervisor. What is a bare metal hypervisor? Fine. We saw in our previous session. When you install your hypervisor on the hardware, directly on the hardware, you call it as bare metal hypervisor or embedded hypervisor. So you have to enable VTX, which is telling your local machine that you're going to be performing some virtualization on your system. So you're going to be enabling it, which is called as hardware assisted hypervisor virtualization. So hardware assisted virtualization will be enabled when you're booting your OS and you have to go into your BIOS and you have to enable it. So when you directly install your hypervisor on your hardware machine, you call it as bare metal hypervisor. And you even have type 2 hypervisor, which is hosted hypervisor. But there is a difference here. You are going to be installing your hypervisor, but not directly on your hardware, but rather on your host OS. So you will be having your own system, which is these are your hardware requirements or your hardware components. So on this, you would be having your host operating system. And upon this, you have your hypervisor. And upon your hypervisor, you would be having your guest operating system. You can install as many operating systems as possible depending on your underlying hardware requirements to effectively use your hardware. So your hypervisor, when it sits on your host operating system, you call it as a hosted hypervisor. So we discussed all about that in detail. Now let's discuss about few more terminologies which plays an important role in the modern day era of cloud computing and virtualization. The first is cloud, and how is it getting differentiated with virtualization? How is virtualization getting differentiated with your containerization? So obviously we know what cloud computing is. It's sharing of resources over the internet, serving the users with on-demand provisioning system. You pay only for what you use. Businesses and enterprises and organizations do not have to invest on hefty amount to own their physical data centers. Cloud service providers are totally responsible for maintaining all those. So without investing on the capital amount, they can get their jobs done, they can get their workloads done, and there are computing resources in the data centers which are providing through the internet to these business organizations. Virtualization is the backbone of cloud computing. Your cloud computing will not exist without virtualization. Virtualization is a concept that has been in existence right from your distributed computing, right from your clustered computing, and hence it plays an important role in building your cloud computing infrastructure. What it does, it helps the cloud service providers to maintain their own data centers and to host their data centers and to efficiently make use of their data centers so that millions of users and end users would be served with the efficient capacity that the data centers are having. What will your virtualization give or what will it produce? It gives your virtual machines, obviously. When you install a hypervisor on your data center and you are providing the resources to the users over the internet, obviously it is viewed as a virtual machine. So there are n number of virtual machines simultaneously or concurrently running on your cloud service. Now the business organizations has an advantage. So what would be that? They don't have to invest on the APIs even. What are APIs? We saw in our previous session, which is a piece of code or intermediary code which starts your module or your software or whatever the development that you have made. Every time you're accessing a servers, there is a module which is totally responsible for finding the resources that is required for a project. So that's your API. The businesses can opt the APIs as a service, which you call as microservices. In those days, that was not the case. The services used to be monolithic. What is monolithic and what is microlithic? When you have a module, when you have a project which is developed and it has got various modules in it, say you have module 1, module 2, module 3, to n, might be any number of modules, right? When one module at a given point of time can concurrently execute the operations that's been coded in it without depending on the other module, you call it as microservice. It doesn't depend on the other module. But on the other hand, when you have one module which is going to be depending on the other module to run its code, and similarly your M2 is waiting for M3 to run its code, it's totally dependent on each other. You call those type of services as monolithic services. These days, virtualization has played a great role in differentiating the monolithic and microlithic services. So your microservices are totally the blueprint of your virtualization. And virtual environments leads to development of various microservices, which enables various services packed within a container. Container 1, container 2, container 3 to get parallelly executed without any interference with each other. So concurrency is achieved on higher rate without any issues in or delay in accessing the services. Next is containerization. So what is a container? In simple terms, let's talk about a container. Say you are working on an important document in your enterprise. You are documenting all your codes, the testing documents, or the test cases, the test suites, and your tests are run, your output, your screenshots and logs. So the document is going to be having all the information in coded format, right? It's going to be having a specific code or agenda in which all the data of how you are going to be testing your application, what are the types of testing that you're going to use. Okay, so when you document it, obviously you're going to take a printout of it. So when you take a printout of it, what would you do? You put it in a file, right? You zip it in a file. So you can view that as a container. If you want to know about the status of how your project was tested, go access the container. You would be able to see the details about it, right? Same thing happens here in your virtual machine or in your virtualization environment, where your containers are again finely grained virtual environments. So say you have a piece of cake, and this cake can be divided into 3 pieces at a given point of time. That's your virtualization. Further, if I divide this into few more pieces, I call it as containerization. I can put this in a container all together and I name it as C1. I can put these pieces together, I can name it as C2. I can put all these pieces together and I can name it as C3. Why do we have to go for containerization when we already have virtualization in existence? This increases the performance of your microservices on larger scale. This increases your concurrency on higher scale compared to your virtualization. When virtualization serves as the backbone, your containerization serves as a highly performing parallelized environment with help of your virtualization. Instead of trying to fully virtualize a machine or fully encapsulating a machine, you can abstract it into a container with only the requirements that you need. So what it is going to ultimately serve the user or serve the service providers. You're not going to be spending on excess computing resources. So the performance overhead is not going to be higher. Your computing efficiency is going to be good. So you virtualize only the programs or only the module or only the services that's been requested by the user. So what happens in the background? So you will be having an app code which could run on virtual environments, on various physical environments concurrently, which is just requesting or requiring the processes that is requesting or requiring is going to be only be limited to that specific container. So what happens when the developer is developing the code? Every time a developer is developing, he packs all the configuration files, the related libraries and other dependencies to run on its own in a container. So everything is viewed as a microservice. So only when it is required, it will be accessed into a container. So that's about cloud, virtualization, and containerization. So with that, I'm going to stop today's session. I will continue in the next session about various types of virtualization. We have server virtualization, data virtualization, storage virtualization. So these are some types of virtualization which we will be covering in detail in the next session. Thank you. Have a good day.